So this is the last lecture in terms of arrays, and it's actually the last lecture, the last virtual lecture in the course. There might be one more just as an interest one, which I might cover recursion with methods. But in terms of what will be tested on the final assignment, final exam, this is it. And it covers an accumulation of everything we've been doing in the course. So one of the most important things is looking at how we can store information. Because if that's not the whole point of using computers, what is the point? Information is what it's all about. Whether that information is just simple numbers for an account, whether that information is processing of data that's coming across a network, or graphical information in a video game. Storing the information, being able to manipulate it, and being able to move the data around in the computer's memory is pretty much the whole point of using a computer. And programming lets us do that, or it lets you control exactly how that's done. So let's take a look at storing information in the computer's memory using arrays. Now we're going to get into using arrays of objects, but before we do that, we will take a look at an additional topic which isn't really covered in the notes, and it's called parallel arrays. So in the languages that don't have object-oriented programming, or at least don't have object-oriented programming easily, the idea of parallel arrays is very fundamental. And understanding how this approach works, you can store almost anything. So the idea of parallel arrays is the concept of tracking data or common data across more than one array in order to store more than one data type. So as the example is on the screen, we've got a name, an age, an account balance, and an address, and maybe some more information that we need to store per person. So let's say this is an account, a bank account that we need to store. So we can look at these four pieces of information, and they are clearly different data types. The name is obviously going to be a string. The age we could assume is an integer of some sort. The account balance will be some sort of floating point. Let's say it's a double. And the address itself, depending on how we structure it. In this example, let's say it's a string. So we've got a string, an integer, a double, and a string that we need to store. Now we know one of the limitations of Java arrays is that for the entire array, the type has to be exactly the same. So if we declare an array of integer, everything has to be an integer. Java doesn't have a data structure, or at least doesn't have a simple one, that lets us store more than one type within an array. An array has to be all of one type. So how could we store this information? These four distinct characteristics. Well, by using the idea of parallel arrays. So we have four arrays here that we could use: an array of string, an array of int, an array of double, and then another array of string. We could store information for one particular client. So that client would be, in this case, the first client, index 0, index 1, index 2, and then all the client information after that. When we look at databases in subsequent courses, and I can guarantee you'll be looking at databases, what we do is call these fields. So the first field would be the name, second one would be the age, and these would be common fields for all the records, and the records themselves would be indicated this way. Now, the way we look at them in databases, we actually flip them around. So we look at records horizontally, and then fields we look vertically. But that's just a convention. So for Java, for this example, we're looking at each array, which is going to be each field type. So the common value across all these customers or clients would be their name. So that's all string. So for the first client, that's their name. The second client, that's their name. So this is the idea of parallel arrays. These four arrays, looking at them horizontally, store information for that one single client using the idea of parallel arrays. Let's see if we can actually organize this and store it in an example program. So let's see if we can actually store that in an example program. So keep in mind that we'll have the name, the age, the account balance, and the address. And don't forget the data types. So what we're going to do is declare the name array. So that's going to be of type string. So that'll be the name array. we're going to have the age array, so that will be an array of type integer. We're also going to have the account balance, and that's going to be a double, so we'll just call that one balance. And then we've also got the address, so we've also made that a string as well. So we'll just keep it short. So here are the 4 arrays that we have. Now I haven't populated them with information. We'll do that in a second for an example. But let's say we wanted to display all the information per one client. So we know that the index itself is indicating which client record we need to look at. So the simplest thing to do would be to write a for loop. So we start at the first index and we work up until some terminating value, so the length of an array. Let's look at that in just a second. And then what we would do is then increment for every subsequent record. So how would we display this information? Well, we would do a systemout.print of which record we're at. So let's just call it record, and that would be I. So we've got the first record being displayed. And then let's say we need to have the name as well. So we will display the name. And let's put a tab in there, and that'll just push the name over. So maybe it lines up a little better. So then we will concatenate that with the name at index I. Now we want to display that particular customer's age, so we'll put in another tab. We will show the age. We will then also show the account balance. And finally, the address of that client. And since that'll be the last piece of information for that line, we could make this a systemout.print line, but let's just add its own little print line there. So this is as far as the example really needs to go in terms of showing the information. This is the parallel nature. You can see that when I is set to 0 or 1 or 2, it's going to describe that same index for all the arrays. So if we go back over to this, we would see that for index 0, we will see the name at index 0, the age at index 0, the balance and the address at index 0. When we go over to the next record or the next client, it will be at index 1. So we can store 4 pieces of information for every customer, yet we don't have to get really fancy with arrays. We can just focus on an array for the name, an array for the age, an array for the balance, and an array for the address. And that's pretty much all parallel arrays are. But here's the tricky part. The tricky part really is all the arrays have to be exactly the same length. If they're not the same length, so if these arrays, let's say the name array only went to index 3, so it was only 4 long, and the age array went up to index 6, so that would be up to 7, and the balance only went up to 1, that wouldn't make the information useful, because that would mean that we would only have 4 names, but we'd have 7 ages. That doesn't make much sense at all. So a customer would have to have all the information present. So all the arrays have to be exactly the same length. So let's make sure that we can do that. Now, in terms of the same length, that also means that it doesn't matter which array we use to indicate the length. We could use the name, the age, the balance, or the address. They're all exactly the same length. So we can just stipulate that and say, I'm going to loop I from 0, which is the first record, to whatever the length is of the name minus 1, and that's what that gets us. And it's going to be the same for all of them. So now let's add in at least 2 customers, and we'll use an initializer list just so that we don't have to do any fancy user input just for this test program. So for the first name, we will type in Bob Smith. That will be the customer's name there for index 0. And for index 1, let's call it Alice Key. So she is the second customer. And for the ages of these two customers, let's make Bob 45 years old and Alice just opened up her account. She's 16 years old. And the account balance, let's say Bob's been working for a while, so he has $65,000 in his account. And Alice, who is fairly young, she's just put in maybe her first paycheck, so that for that week, let's say it's $400.55. So that's her balance. And then the address, well, just so we don't get too long in terms of the output, let's just put 123 here Street for Bob, and for Alice, we will make her live at 32 124 their drive. So now we notice that all the arrays have exactly the same length. They all have two elements within them, and they all have their appropriate data type. Let's see if this actually displays anything proper on the screen. So what we should see is for the record 0 and then 1. So 0 will be Bob Smith, and then 1 will be Alice Key. So there we go. So for record 0, Bob Smith, 45 years old. He has actually $650,000. I gave Bob a lot more money than I thought I would. Actually, it is 65,000. My mistake. And then 123 here Street. And then record number 1, it's Alice Key. She's 16 years old, $455, and she lives at 32124 their drive. So we can actually manipulate that information appropriately. Now, of course, if we wanted to do more to read and write the information to a data file, we would have to store the information in a way that we would be able to get it back. So we would probably store all the information in the proper format so that we could retrieve it properly. But we've looked at how we could also manipulate arrays. We would have to write the code so that we would be manipulating all 4 arrays in a very similar manner. So if we wanted to, in this case, we displayed all this information. We did it for all 4 records with index I being the same value for all 4 arrays across that one record. If we wanted to populate this array, we could declare it for, let's say we've got 100 clients, declare it for a length 100, and then read that information appropriately. We could probably read it for the first record at 0. We could read in the name, the age, the balance, and the street, and then go to the next record and read Alice's record, and so on. So this is the idea of parallel arrays. It lets us store more than one piece of information per record using arrays, even though arrays themselves are limited to only storing one data type. We just use an array for each individual data type. And that's actually a really powerful way to store information using the idea of parallel arrays. Databases actually use this idea. Programming, though, especially once we look at object-oriented programming, we don't use this idea. We use another idea of using a data class to store individual records and then span that across an array. So that's where we're going to lead into arrays of objects. So let's use the same idea that we did using this name, age, account balance, and address, but we're going to do it as an array of objects. And let's actually see how that works. So what does it mean to be a data class? Well, a data class is very similar to all the other classes you've been writing in Java, except the data class doesn't have all the proper security put around it. It doesn't have private members, it doesn't have private attributes or private methods. It actually doesn't have any methods at all, and it doesn't have any accessors or mutators. As I said, there's no methods at all. There's no constructors, there's nothing. So let's take a look at an example here. So we're going to have a data class, and a data class example. We're going to store that information, the name, the age, the balance, and the address. So how could we actually store that information? Well, the first thing to look at is, what does the data class look like? Now, in Java, you could actually, if you wanted to, within this class, you could have an embedded class. What is an embedded class? Well, an embedded class is a class that only exists within another class. So this class right here is inside this class. So you'll notice that the class itself, the program class, goes all the way to here, but this class is actually inside. The way we would probably have to do this in Java is to actually save this as a class called data. But for this example, we're going to actually put this class right inside this one. Not something that you actually see very much in Java, but for the sake of this example, it works very well. This program is the only one that's ever going to use this class. Therefore, storing it in here along in parallel with the main method, so it's sort of a brother to the main method here, it actually works very well. So we're going to, let's see, compile this guy here just to make sure that the syntax is right, and you can see this class can be used, which means inside we can actually declare objects of this class. Now let's take a look inside here. So what we've got is the data elements. We've got the age, the balance, the name, and let's go ahead and add the address. There we go. Now you can see that this class right here has no constructor. It has no get or set mutators or accessors. There's no toString method. There is nothing. The only piece of code that's in here are the attributes themselves, and each attribute gets an initial value. That's actually very important as well. And the class itself is data, and they're all public, which means in the code we can access each one of these attributes without having to use any of those methods. So let's see what the code looks like. So what we have to do is declare an object of type data. Let's just see how this works for the data class. So we've just declared an object of type data, and we know that these values have initial values. So each attribute has an initial value, and if we display it, let's say person 1, we're going to show their name. So we should see, well, that's actually not a very good example. Maybe we should show the age so that we see a 0. If we displayed the name or the address, we would get nothing on the screen, and that really wouldn't show much. But the age at least should show 0. So let's compile it. And what's the error here? Non-static variable. So what we're doing is trying to reference data within a static method here. And I neglected, for this example, this needs to be a static class inside this program class, because everything here is static. If this was declared outside as its own data.java file, we wouldn't have to do this. But in this example, we do. So let's compile it again and run it, and what we should see is we get a 0 on the screen. So we're properly accessing the age here. So let's go ahead and manipulate it. So let's change the age of person number 1 to 45 years old. And there we go, 45 years old. Let's go ahead and create another person. And let's change that person's age to, let's say, 16 years old. And let's display that person too. So there we go. So for person number 1, we've stored their age, and for person number 2, we've stored their age as well. Now you can see with this data class, we've changed it up. Instead of using the idea of parallel arrays, what we've got is an array, or sorry, what we will have, if I can get back there. What we will have eventually is a single array with all the information per each element. So what we're going to eventually have is an array of objects. So you can see here that we've got the person object, person number 1, we've got the person 2 object, they're of this data type, and we can manipulate each attribute per that object. So now how could we populate all of the information per that one person? We don't have a constructor, we can't use initializer lists, so we have to actually go the long way. So before we create the array, let's go ahead and actually populate the information for Bob and for Alice. So there, I've quickly gone ahead and populated the information for the first client and the second client. So we can see that person 1, that's Bob Smith, 45 years old, $65,000, and he lives at 123 Here Street. And then second client is Alice Key with her information. Now, how could we display the information? Previously, when we looked at objects, we could actually just display the object itself. We could just say, hey object, why don't you just display yourself? So let's try that in this context here. So let's just display, and what we see is a crazy data class example, $data at whatever. Why isn't it displaying Bob Smith? Well, if we look down in the class, you can see in this data class, there is no toString method. So by default, what Java does is it shows us the memory address. And because of this syntax, this class right here, the data class, belongs to our data class example program. So what we do is we get the memory address for this particular object, which is person number 1, within as of type data within this program class. So there's a couple of options we can have here. One option is to add a toString method to this data class, but it's a data class, and the idea is that we don't add anything that we don't need. Or we could write a method inside this program which displays the information for a particular data object. So it shows all that information. And let's go ahead and actually do that. So I'll quickly add that one in here. So here we have a method. I've decided to call it person record because it's going to return back the record of a particular person. It has one parameter, which is an object of type data. So this is using the idea of passing in an object into a method. So we're going to pass in an object of type person. Now keep in mind, this is just going to be like everything we've seen before. This is not going to be the entire record or the entire object. What it's going to be is the address in memory for that particular data object. So when we reference any one of these here, the name, the age, that is going to be the reference, the memory address of where that object exists in memory. So keeping in mind, that's what the parameter is going to be, is the memory address. It's called person record, and instead of doing systemout.println, what it decided to do was have this method return back a string with all the information formatted in a way where we show the name, the age, the balance, and the address. So that's how we're treating that, that method. So let's go ahead and display it. So what we're going to do here is call person record, and we're going to pass in the memory address for this particular object here called person 1. So now what we should get is Bob Smith's information showing. And here we go. His name is Bob Smith. He's 45 years old, has $65,000, and he lives at 123 Here Street. And if we wanted to show Alice as well, we could then call that record and show person 2. So we pass in the memory address for that, that object, person 2. And what we should see is Bob and Alice's information. So this is the idea. Instead of using parallel arrays, the idea is to use individual objects that hold the information. So how can we transform this into then storing a lot of clients within this? Well, let's create an array of objects. So let's change this program around a little bit. So I'm going to save this as something new. I want to keep this program around just for comparison. So data class example with arrays. So we will change it. So the difference will be in how we define the array and what it holds. So let's take out the person objects here, and what we've got is a new declaration. So in this case, we have an array of data objects. So every object is going to be of this class right here, of data class. So we will call it, let's say, people, and this will be a new array of how many objects. We've only got 2 here, so this will be of data 2, so of size 2. So we've got an array of that many objects. Now, in terms of this array, we now have declared an array of memory addresses. We have not actually created the objects at this point. So what does this look like in memory so far? If we go back to the notes, and just using this as an example, ignore the fact that we're talking about arrays here. We're just looking at the bottom part. What we've created is an array of 2 elements, so 0, 1, and 0, 1, and 0, or 0 and 1. And each one of these is eventually going to point to an object of type data. But they have a null in them at the moment. So what we actually have is an array here called people, with each element holding a null in it. So the first one has a null, and then the second one. So this would be object at 0 here, and this would be object at 1. The default, of course, is always a 0, and for reference variables, a null is that equivalent of being a 0. So we actually have to create these objects before we can actually put anything into them. So let's go ahead and create this array with declared objects. So the simplest way to do it is probably just to say people at 0 is going to be a new data object here. So this create a new object, return the address for it. So this creates a brand new data object, just like we had before, and it returns the address and stores it into this memory location here. And then we do one new data as well. So this creates the 2 objects in memory. The 2 data objects in memory, returns the addresses, and stores them into the array elements. Keep in mind, what does this define here? This defines an array called people, but each element is going to be an object, which literally means each element is going to store a memory address. And what we've done here is we've determined what memory address to store into each one of these elements. Because by just doing this declaration up here, all that did was create an array of memory addresses, with each memory address having a null pointer inside it, or just a null. So now we can actually populate this information. The other way to do this, the proper way, especially if you have, let's say, 1,000 or 1,000,000 clients, declaring each one like this would be a very long program. The simplest way to do it is a for loop. So what we do is process an index I here. We're going to go up into the length of the array -1, which is what that gives us, and then I++. And for each element, we're just going to say for people at I, so for that array element, you're going to be a brand new object. So these 2 statements are equivalent, except this one processes all array elements, not just the first 2. Now, of course, we only have 2, but this, if we had 1,000,000, this would process all 1,000,000 records and create objects for them. Now, in terms of populating them with information, we would probably use another for loop, maybe read in the information from a data file. But in this context, the simplest way to do it is to just say, why don't we just populate them manually? Because we don't have that much information, and we know that the information for Bob is stored immediately in the first element, and the second element is going to be Alice's record. And you can see the notation that I'm using. We'll talk about it in just one moment. There we go. So let's go back up. We've declared this array of objects. We've declared each object and then stored it into the array. So at this point here, we have an array with proper objects, except every object here is zeroed. So the age is 0, the balance is 0, and the two strings are empty. They're just empty strings. They're real strings, but they're empty. So now we're going to populate them with information. So we were going to use the attribute and assign a value to it, but look at the notation. The notation has the array itself, which I should be calling people, not person. Let's make a correction to that right now before I continue. There we go. So what we have is the array itself at index 0. So this part right here is the whole part that denotes the object. So the object itself, we'll put it in the comment here, the object for that person is people at 0. So that's the object. Now we want to refer to the name that belongs to that object. And there's the dot. The dot comes after the square brackets. So this part right here is to denote the object. The dot is to denote which attribute. In this case, we're manipulating the name for that particular object. So we're storing the data for Bob. He's the one at 0, and Alice is at 1. Now we actually need to display the information. Now we could display it for each individual one like we did here, but we went ahead and used a for loop to populate the objects. Why don't we use a for loop as well to actually do the display? So let's whip up another for loop here. This will go set I for the same exact range will be people.length. Oh, if I could only spell today. I'm terrible. So up until the length and I++. Now what we're going to do inside is display the particular record that we're at. So we're going to do an I and then display the value I. So we want to know which record it is. And then we're just going to call the person record method that we had below. So you can see we've got the person that we need to pass in. So we need to pass in the memory address or the reference to that particular data object, which is whichever person we're looking at. So we're going to call person record, and then that is going to be the object at I, whatever it happens to be. We're not done yet. There we go. So we're going to loop through the array of people, the array of data objects. We're going to print out each individual one, so this returns back a string. We're going to pass into it the address of that particular object called, in this case, well, person. So it'll be the address of that particular data object. So let's see if this actually gets us what we want. Let's clean this up a little bit. Let's add a tab in here as well. There we go. Clean up this data just a little. There we go. So we're looping through all the objects in the array. So the first object is going to be Bob Smith. He's 45 years old. The second object is going to be Alice Key. So the person record method only deals with one object. It doesn't know about any arrays. It's not aware of arrays. The data class is only storing the information for that particular object. So that particular object's name and address and so on. The magic happens up here. We've declared an array of these objects. We had to create each object and then return its address. Now at this point, each object is going to be empty, which of course is probably the only way to do it. We don't know what information to store in a loop, especially if there were a million records. We don't know what the information will be. Later on, we could probably use maybe a loop to actually read in the data from a file, but in this case, we just went ahead and populated it directly. And then we went ahead and displayed that information. So we just went through a loop that went through all the elements. And then for each object in that array, we passed the address of each object into the method, which went ahead and displayed that. And that gave us our output. So this is a very simple database of storing client information using a data class. Now, a data class is a fairly advanced concept, even though it's so simple to use. But the idea is it's not a very secure method, or sorry, a secure approach to storing information, because we could store anything we want. We could store in an age of 0 or a negative age. A negative balance, maybe where there shouldn't be a negative balance. And maybe the name and address should always be populated, but in this case, we're permitting them to be empty. But we're the ones controlling this program. We even put the data class inside this program class because we have so much control. But this isn't the only way to use an array of objects. When we're actually using an array of objects, the idea is to have all the capability of these array of objects. So if we look at them, let's go back over here. So with an array of objects, we want to have all the ability for each object. So if we look at a string, an array of strings, we want to have every string be able to tell us its length, every string be able to do a to uppercase of its own data. And that's the idea of an array of objects. But one of the most important things is what we've already seen. Each object stored in the array must be instantiated separately. And that's this example here. The array of objects does not have anything within it in terms of data. All it has is a bunch of addresses, which initially are null. So what we did was we created an object for every single element in the array and then assigned its memory address. Once we have that, then we have information that we can manipulate. We're going to take a look at using the die class as the next example of an array of objects. So we're going to have an array with multiple dice in it, which will be fairly interesting. So let's take a look at that. So to create an array of die, we're going to use, instead of the simple die class, we will use the multi-die class that we talked about. So in this example, what we have is a class called multi-die. It has two attributes within it, the sides and the face value, and both of these can change. So the sides is the number of sides within the die. The default is 6, but we could have a die which could have 2 sides, so that would be similar to a coin. Or if we play adventure board games, such as Dungeons and Dragons, you could have die that have up to 100 sides. So we can have objects with different number of sides. We have a constructor here, the default constructor. As soon as you create an object, it will immediately roll it, so you get a random side. We can also create objects that have more than one side, and then we just roll it immediately. We can do a manual roll as well, which means we've already rolled it, but we'll roll it again, and it returns back the side. And we've got some getters and setters. So we can set the face value, so we can manually move the die, set the side to whatever we want, and we can also get the face value. So after a roll, we can get the value of the die without having to re-roll it. And we've also got a nice two-string method, which tells us the number of sides and the face value current. We've also got equals, a couple of equals methods, and then we've also got a copy method, which we looked at, which was to make a copy of one die to another. So we would copy the sides and the face value. So we'll use the multi-die class itself. So how do we go ahead and do that? Well, if we wanted to create just one die, so multi-die, we will call it, let's see, test die here, and it will be new multi-die. Let's give it a 20 sides on that. So what we're going to do is call the second constructor here, which has the number of sides, and immediately it's going to do a roll. And let's display that value as well. So systemout.println, we will show test die. So we're going to declare a die object here, and we're immediately going to show what its value is. So let's run it. And there we go. So it's a 20-sided die, and the face is 9. If we do it again, we can see that it's properly doing the random roll as soon as it creates the object. So how do we go about and create an array of these things? Well, literally, let's create an array. So we'll call this one dice. And let's create an array of only 5 of them. There we go. Now, what can we do with them? Well, by default, this created an array of multi-die objects, but each is null. So each element is null. And let's actually see what that value is. So let's display dice at 0. So just the first one. Let's just display the first one. Let's not go through all the elements. Let's see what we get if we show this. There's our null. So you can see every object in this array has a value of null. And you know what? Let's just go through and display all of them, just to see if they're all set to null. And we will show at I. So what we should see is 5 nulls show up on the screen. There's our 5 nulls. So these aren't pointing to any die objects yet. And if you notice, we haven't done a new multi-die object declaration. We haven't used any constructors. This is just to create the array, so that the array with each element is a multi-die object. But now we need to actually go ahead and create these objects. So let's go ahead and do it. So and what are we going to set? Each die object here is going to retrieve the address of each die element is going to retrieve the address of a new multi-die object. So if we use the constructor, the default constructor, if we go back over here, we'll see that it sets the side to 6 and it does an immediate roll. And then down here, we would show each individual die object value. We'd be calling the toString method. Of course, we shouldn't be getting a null. So let's see what happens. So this should set it with the default constructor to 6 sides. And then the face, of course, we don't know because it's a random roll. So let's see what happens now. All right. So each one of these is 6-sided die, and the roll is random. Let's run it again. We can see we've got random rolls coming for each die. Perfect. That's actually rather interesting. So let's say if we wanted to modify the number of sides. So in this case, if we just set it to 2, this would set it to 2 sides. And we would see this would simulate a coin flip. There we go. So where it's almost like we're flipping a coin. It's side 1 or side 2. But what if we wanted every die to have a different number of sides? Now, of course, the minimum number of sides truly is 2. It would be a coin. A one-sided die is fairly useless. But let's increment this and add I to it. So what we start off with is I at 0. Now we've got 5 die. So each time it's going to start off with the first die at 2-sided, the second die will be at 3-sided, and so on, because we're going to be adding the value of I to it. So this would be, well, I don't know which number of sides, it depends on which object. So now we have a die with different number of sides, and should be different number of roll values based on those number of sides. This is a classic array of objects. Each object is unique in terms of the number of sides. They're all, of course, multi-die objects, but they're all slightly different from each other. They all have a different number of sides. Very similar to an array of strings, where each string would have its own different type of content. Now, of course, we can roll each die maybe let's do that in a loop. So what we'll do is we'll declare another loop here. Let's do it afterwards so that we can do a separate display. So int I at 0, I less than dice dot length. And what we're going to do is call the roll for every die. So dice at I dot roll. So you notice again, this is the object. So dice square bracket I is finding the appropriate element in the array. Once we find the appropriate element, that element has the address to the actual die object, and then we call the dot. So the dot corresponds to the actual object, and we're going to ask it to roll. So let's copy this display here, and we will show the die. So we'll show it initially when it gets created. We will do another roll, and then we will take a look at the die again to see if the rolls are different. So there we go. So we see the first roll. Let's see, we've got 5 die, so 1, 2, 3, 4, 5. So we should be down here. So that should be 1, 4, 1, 2, 3, 1, 4. So we can see that each die is re-rolling. Just for the sake of clarity, let's put a systemout.println here. Put some dashes to separate the initial creation and the second roll. Let's take a look at this one. So there we go. So each die with a different number of sides is getting rolled independently. We have a lot of control over this array. So this array is a number of die, which is actually pretty cool. Now, what else can you do with this array of objects? Well, one of them would be, number one, to display all the values, which we've done. So let's write a method for that. Let's write a really quick method. So this one will be a systemout.print or .println, so it's not going to return anything, so it's void. And we pass into it an array of multi-die objects. We'll just call it list for the method itself. So it will be whichever list it is. So down in here, we will do a systemout.println. Actually, we'll have to do a for loop because we do have that array. So what we'll do is we'll copy this one over here, and instead of calling it dice, we'll call it list. There we go, and it just displays it out to the screen. So we could just easily then call it. So we could say display dice. We pass into it the array itself. So this literally display the entire array of multi-die objects. And what we can do is then call it again down below after we've done the roll. And there we see that we've rolled it multiple times. So we see the number of sides. Number of sides really indicate which die we're looking at, and you can see that the rolls are different. Now, what else could we do? Let's say this is part of an adventure game. So you're writing an adventure game, and the array itself of these five die objects, the total value is maybe the particular score that you get for an event that happens. So you're wandering through the forest and you have to roll all 5 of these die. These 5 die have different number of sides. So 2, 3, 4, 5, and 6. Of course, the die with number of 6 has a probability of getting a 6th side showing on it. So it has the largest weight. But let's say you add all of these together, and that's actually what your score will be. So how do we add together all the values of the die? Well, we do have, if we looked at it, we did have a method here called getFaceValue, which returns back the face that's facing upwards on that die, which is really the side that's facing up. It's the number. So let's declare a variable here called total. And what we're going to do is add up all the die. So let's comment out this display up here. And let's keep this one down here because this is going to show us what the total will be. So we'll go through all of the die objects. And for each one, we're going to return back and accumulate the value that's facing up for that die. And then we'll display it. And I probably mistyped it. Get face value. No, it returns back an integer. And of course, I made the mistake of not indicating which die object. Get face value does not belong to the array, it belongs to each individual object. So the compiler picked up that error that I was making. There is no get face value method that belongs to the array. The get face value method belongs to the object pointed to within the array. And there we go. So if we add those together, we've got 6 plus 5 is 11. Oh, excuse me. 6 plus 5 is 11. So yeah, we've got the total now. And you can see how little code there actually is. If we increase this to, let's say, 100 die or 1,000 die, with that small change, what we have is a program which declares 1,000 die objects, and eventually we'll have the total of 254,779 is the face value of all these die. That is super cool. And of course, to make things a little faster, if we didn't display anything, we would get to the total much, much faster. So we have this wonderful tool now, which is part of our game, which holds 5 die. Each die has a different number of sides, and we're able to roll all the die. We have a for loop here that lets us roll all the die. We can display all the die, and we can total them up. So what if we wanted to use this idea here of creating the die objects, doing the initial roll and creating them and doing the initial roll? Could we write a method that returned back the array? Well, we've seen it before, where we actually wrote a method which returned back an array that it created. Let's go ahead and do that. So what we're going to do is write a method here. So create an array of multi-die objects and return it. So let's call this one create dice. And what it has is one parameter which tells us how many die to create. So number of die. And what it will return back is the array of die. So we'll just call it list that it returns. So what does that look like? Well, it literally is these two statements here. So what we're going to do is copy this and paste it in. So instead of calling it die, we're going to call this array list. How many? Well, that's going to be controlled by number of die. And the array itself, we're calling it list locally. And it returns it. So keep in mind, we've got this method. It's going to return back a multi-die array. That's its data type. So it's returning back a memory address. It's going to be called create dice, and it has one integer parameter. So this is going to be that is the signature. This whole thing here is the method header. So let's call this. So we're going to create a multi-die array. We're going to call it dice, and it's going to be assigned whatever this method here returns back. So you notice that this method returns back an array of multi-die objects, and that's exactly what this reference variable is going to store, a reference to an array of multi-die objects. So we're going to create the dice. We're going to create 5 dice, and let's see if this actually does what it's supposed to. Maybe if I put a semicolon there, it'll work. Look at that. So now we've create an array of 5 dice, which means we could create another array as well. And let's make this one 1,000. So now what we're going to do is we're going to have dice that have some pretty strange number of sides. Because remember, when we create these die, we've said that it's 2 plus I, so I itself is going to be going up until the length. So we know that if we pass in 1,000, I will be going up to 999. So plus 2, that should give us 1,001. We should have number of sides up to 1,001, I would think. So let's go ahead and do some displaying. So we'll leave this as it is. We'll do a nice little systemout.println here to separate our output. And let's display the more dice array. So for this one, we're just going to say display dice, more dice. Now keep in mind, this one is 1,000 long. So there's 1,000 dice, 1,000 dice in this one. It's going to take a little while to display. And then what we're going to do is maybe do the totaling. Now the totaling, we've done it as a for loop. Maybe we should write this as a method as well. I mean, if we're doing it for more than one array, it's getting a little tedious to do a copy paste. So let's go ahead and do a total of that. So public static, it's going to return back an integer. And let's say total of dice. It's going to get passed in another array. We'll call this one list as well. And what it's going to return back is that total. So we'll just declare something here called sum, just to be a little bit different. And let's copy this method down here. Oops, let's copy that whole routine. And we'll put it in here. Oh, I don't think I should have copied total. Let's move this back out here, because we still want the total up here. We still need a variable to store the total, but it's going to be the total of the dice. So in this one, it'll be array dice. And then we're going to return back the sum. Now, in this case, we're not calling it total inside. We're calling it sum. And the array itself is not called dice, it's called list. Because we don't know which one it is, it's whichever one is going to get passed in by the parameter here. But for each die object, each multi-die object, we're going to ask its get face value and add it to the sum and return back the sum. So what we've got here is a total as well. So we've got total of the first array. And let's display the total. So what we can do is total is going to be assigned total dice of the more dice array. Now we don't have to redeclare total, it's already declared up here. So let's display this one down here now. There we go. So what we should do is total up the dice array. We're going to display it. We're going to display the more dice array and total that one too. So let's take a look at what we've got. So it'll take a little while to print out. It's taking its own sweet time. Output always takes longer. So there we go. So we can see that for this one, up at the very top, we've got our dice array, which only has 5 die in it. So we see the sides, 2, 3, 4, 5, 6, and the totaling for those random rolls. And then down here, we've got our sides, which are increasing. And you notice that the size for the last die is 1001 because it's 2 plus the number of die that we have, and it rolled a 50. But it totaled everything up. And if you look at the syntax, what we've got is an array of die objects here, or two arrays of die objects, and the first one is being manipulated here, and then the second one being manipulated here using these methods: display dice, totaling dice, and then we've got our create dice method as well, which helps us create the die objects. So the purpose of using methods, of course, is to encapsulate an idea, but it also helps reduce the program code. So our main method, if you think about it, is actually doing a lot. It's creating two arrays of die objects and also performing the random rolls by using the constructors within each object. That's what's happening here, where every time we're creating a die object, it gets randomly rolled. We do another roll here, which we didn't need to do, but hey, doesn't hurt to do a second roll. We display these die of the list of 5, and then we go ahead and do the other one for 1000. This is actually a pretty interesting program. So you can use this idea as well for the puppy class that we looked at. So I wonder if we can find the puppy class. There's our puppy class. So the puppy class itself actually had all these various attributes, all the methods, we had the proper constructors. So technically speaking, if we wanted to, for our shelter game, in this case, we only created three puppy objects. But later on, what we could have done is created an array of puppies. Let's say we created 40 puppies. This animal shelter has a lot of puppies for adoption. You should get there and adopt one. They're getting lonely. But when we first, at the moment, we haven't created anything. This is our first creation, which is the array. All these puppies actually have nothing in them. So if we wrote a for loop, and displayed each puppy, and we can just do it like that because this should call the toString method for each one, or it should. But we'll see that what we do get is a bunch of nulls because we haven't created the puppies yet. So in this case, what we should have is a for loop, which goes ahead and creates each puppy. So what we want to get is the address for creating a new puppy object. Now we can't use anything like this. We can't say Piffles and Shasta because this is a for loop which is fairly consistent. We can't put all the variableness in there. But what it will do is create a puppy object, the default puppy object. And if we look at the default constructor, all it really manipulates is the puppy ID. The puppy ID gets added by 1. All the other values have these the other attributes have these default values. The name is no name, the age is 0, the gender is male, it's neutered, neutered is false, hunger at 5, exercise 5, and it's not pregnant. So that is what we should see for all these 40 puppies. The only difference will be the puppy counter. The puppy ID should be whatever we've left off. So it should be puppy ID number, or the first puppy, the second puppy, the third one. So the first puppy in this one will be the fourth puppy. So let's see what actually happens now that we've actually created our puppies. There we go. Let's go up a little higher. So we should see that we've got no name, which is that default puppy that was created up here. And then we have Piffles and Shasta. We do some output for Piffles and Shasta here. And then we start with our next puppy. So 4, 5, and 6, and you can see all the puppies are identical to each other. And we're at puppy day 43 because we created these 3 puppies here. So using the puppy class, we can create an array of puppies. We don't have to modify anything in the class itself, because what the class is doing as part of object-oriented programming, it's encapsulating one puppy. And what we've got in our example here is an array of puppies. Each element in this array of puppies is a single puppy. Therefore, everything that works with a puppy class also can work with an array where each element is a puppy as well. And we could probably do stuff like figure out the average of the puppy ages, or count up how many puppies are neutered. We can actually count up those. Let's do one last example of the die class. So what if we added up all the number of die that have an even face for this one that has 1,000 die? So what we're going to do is a total of evens. So we're going to have another for loop. And in this case, we're going to ask a question. If the more dice object at I, if its get face value modulus 2, if that is 0, that must mean this is even. In that case, I want to add 1 to total. Again, if I could spell correctly, this would be a much better example. And of course, this will take a little while. And if we went ahead and actually processed it, we would see that, for example, the 896 would be added into this count. We had 488 die in this list of 1,000 that had an even face in it. And if you think about it, that's actually pretty consistent. Because, if you look at the number of die that are even odd or even, that's about 50-50. And since we had about 1,000 of them, we didn't really have, we didn't bias odd or even. We had 1,000 of them. That's actually pretty accurate. If we ran it again, it should be close to that 500. And 488 is close to the 500. There we go, 490, even getting closer to the 500. So we could even do statistics with this randomness. But that is actually the last topic, which was arrays of objects. The Chapter 7 notes actually have a couple of other ideas, which were we looked at command line arguments, which was the idea of string args, so we were able to pick those up. We didn't cover variable length parameter lists, clearly a topic that's going to be left for another course, but I will tell you that in my experience, I have never used variable length parameter lists, only because my programs are fairly tight. I don't write classes for other programmers. I usually write the classes specifically for myself. This would be an example where you'd be writing a class for another programmer, and you want to give them flexibility. I'll let you read that one on your own. Now, the last idea, though, and we're not going to look at it in this course at all, is the idea of multi-dimensional arrays. So the book mentions two-dimensional arrays, which makes sense. All arrays aren't one-dimensional. But the secret is that Java doesn't actually understand two-dimensional or three-dimensional or n-dimensional arrays. So the syntax is written like this. So you can see that what we have is two square brackets, and then we have dual square brackets over here. So the first one tells you how many elements are in the first dimension and then in the second dimension. And it's essentially almost like a grid, except this is a lie. This is not how Java declares arrays. This is how C and C++ declare arrays, and a number of older programming languages like BASIC, Fortran, COBOL. This is how they declare arrays. Modern programming languages, especially ones that are object-oriented, actually declare the arrays like this. And if you think this is complicated, it is. So this is how Java declares a two-dimensional array. So we've got the syntax here, and we've got the name that refers to the very first element of the entire structure, and then we declare how many elements within each one. But what it says is we're going to create an array of 5 elements. 1, 2, 3, 4, 5, indexed from 0 through 4. But what is each element within this? Each element within this is a reference to an array of 10 elements. So this points to an array of 10 elements, this points to an array of 10 elements, that one. This does not look as clean as this picture, and it definitely is not. This is how Java actually declares them. So as far as Java is concerned, everything is a one-dimensional array. Even if you declare a two-dimensional array, what you're declaring is a one-dimensional array where each element refers to another one-dimensional array. It does make the code a little bit complex. It does make it a little tricky, especially when you have to declare them. If we go back into the code here, when we created our first one-dimensional array of these objects, we had to create each object. Well, when you do a two-dimensional array, you have to not only create the first array, you have to declare that one this way. You then actually have to have a second loop, which goes through this array of 5 elements to declare the subsequent array dimensions. It actually gets fairly complicated fairly quickly. If you can avoid using more than one dimension in a Java program, you should. Multi-dimensional arrays are only necessary if you can't avoid them. Really, what you should be doing is using the idea of a data class. If you wanted to store multiple elements within one object, or use the idea of a parallel array if you wanted to store more than one value in single dimensional arrays. If I could find that example here. So this would treat one-dimensional arrays where you can have multiple information. So this is a much cleaner, much easier to program approach versus a two-dimensional array. Now, Java does let you do multi-dimensional arrays. How many arrays or how many dimensions are possible? As much as memory permits. So Java could easily do a 12-dimensional dimensional array. But this gets even trickier because what you have is the first dimension where each element is another array. And if we look at this one, this array element here points to another array, and the subsequent dimension points to another array, and the subsequent dimension points to another array. That code gets very tricky very quickly. If you can avoid doing this, you should at all costs. And that's where I leave it for this course. This is the last topic we looked at, which is chapter number 7. There might be one more virtual lecture which will not be covered on any material, no final exam assignment or any exercises, which will be recursion for methods, and that'll just be out of curiosity. It's an interesting topic, but it's something that you will look at in the next courses and so on. So this is it. Thank you very much for listening to these lectures, and have fun doing all the exercises. And as I mentioned at the very beginning, go through the chapter 7 notes, but do focus on the topics that we covered. Thank you very much for listening. Bye-bye.